Hi guys, I was looking through and having a go at the exercise myself, and I noticed a few questions that I anticipate some of you might struggle on. So I thought I'd make this video just so that for those who are struggling with some of them can have an understanding of what's going to happen. So I'm going to specifically look at 2g first up. So f of x, and we've got a graph y squared equals f of x. We've got the graph f of x is equal to x cubed plus 27. Now, x cubed plus 27 is a graph. It's a cubic graph. It has a y-intercept of 27, and it looks like this. Now, the reason I chose this one is because the answer has a really, really weird kind of exaggerated curve. Now, the reason the curves on this graph are like that is because we purposefully, when we draw graphs, we purposefully exaggerate the curves on a graph to show the marker that I know that those curves are there. So basically what we have to remember is when we have cubic functions and we're taking the square root of the graph, the kind of curvy bit still remains the same. And that's based on the notion that when we take the square root of a function, it slows down how fast our function is increasing. So we know our basic rule of thumb when we take the square root of a graph is to delete that. We also know my y-intercept is going to move down to the square root of 27. Now you can write the square root of 27, or I think it's about around 5. I think, yeah, 5 times 5, so it's going to be around 5 with the square root of 27. And then what we need to do, before we even think about doing y squared, we need to graph the positive square root of f of x. So I can see from here that it's going to be a very similar graph. It's going to go up, but it's going to increase a bit slower. And then it has to curve back down here. Now, the answer, you can see that that curve is very exaggerated. So if you like, you can draw it like this. We're basically remembering the premise that this bit is decreasing the rate that it's increasing. So if we decrease the rate that this is increasing, it's going to look a bit flatter. Because a big steep curve, the less it's increasing, the flatter it's going to look, which is why you see the answer is so exaggerated. Then, of course, when we do y squared equals f of x, we just reflect that down to there, and that's why we get that. But the concern that I anticipated some of you might have in the answers is this bit in your answer is quite long, and the bit I've drawn is quite small. The only reason they've done that is because their graph is very stretched out. You can see that they've got a scale that goes up by 2s. Our scale goes up by 27. So if I stretched my graph, if I pulled the top and the bottom and I stretched it, it would look like the answer. So when we think about graphs, if you're worried that your answer's wrong, think about the perspective of the graph. Think about your scale and think, if I made the scale of my graph the same as the answer, would mine make sense? Same idea for question H. We can see in the answer that the circular bit in the second and the third quadrants is very flat. That's just because our graph is quite small. It's quite stretched out in this one. No, it's quite smushed. Sorry, it's quite squished. So that's why our circle looks quite small. Let's have a go at drawing it though. So I have f of x is equal to x minus 3, x minus 1. So I'm going to draw my y-intercept. So I've got 1, minus 3, and 0. I know that that's a positive graph. So the graph is going to look something like this. Now, I don't really know what this point is. We could find out what the point is. Well, I know that this has to be halfway in between minus 3 and 1. And 0, sorry, so that's going to be minus 1.5. If you plug that in, you get minus 1.5 and 6. So remember, when we take the square root of a graph, our y values are also square rooted. The square root of 6 is quite small, so we're going to have it down here. That's why this bit is so flat and not very circular. It's because the square root of 6 is such a small number compared to 6. Then, of course, we can get rid of the bottom half of our graph. And then of course we're going to have in black over here the same type of graph, it's just going to increase less. And then we have this, and then the same idea, that's going to happen like that, and then we can get rid of the red portion and we're done. Okay, the other one that looked a tad concerning was the one after it, I. So we've got the graph f of x equals x plus 4, x minus 2, x minus 1. So that graph, let's have a go at graphing it. Remember, if I don't know if I followed the conventions properly, but remember in my other examples, but remember here that has to be a y there and an x there. We have to put arrows on all of the ends. I've got x-intercepts of minus 4, 1 and 2. It's a positive graph, so it has to look something like this. It's going to go down. I'm going to go, okay, where's my y-intercept? Well, it's going to be 4 times minus 2, which is minus 8, times minus 1 is 8. So it's going to be up here at 8. It might continue up a bit, and then it's going to go back down. So our graph's going to look something like that. Now, the answer has, it's quite stretched. Let's think about the perspective again. If I stretched my graph, this bit would look taller like it does in the answer. The reason that mine isn't as tall as the answer is because I haven't figured out exactly what this point is. It's a good rule of thumb to figure out what it is. So halfway in between 1 and minus 4, well, if I plus those two there, I get 5. Divided by 2, I get 2.5. So if I move this way by 2.5, I get minus 3, and then minus 2, and then minus 1.5. It's halfway in between. And if I do put that in, just let me quickly see what I get. So if I put in 1.5, I get 21. So now you can see why that graph goes all the way up to 20. It's because that point up there is 21. Okay, so then what I would do is, well, we're taking the square root, so of course we get rid of the bottom part of the graph. And then, well, we know our square root. Over here, it's going to have our same type of function. It's just going to increase less, and it does get a bit more curvy. I might fix that. So it's going to increase less and get a tad curvy. And then here, well, let's take the square root of 21.875. We get about 4, so that's going to be all the way down here. But we've also got our y-intercept, which was 8. If we take the square root of 8, we get 2, so that's going to be down here. So yeah, we can see that's what's happened in our graph. So we've got, if I delete the red bits, we've got this funny shape here. Now if I stretched my answer, if I got the top of my graph up here and the bottom of my graph down here and I stretched it, that graph would be as curvy as the answer. The reason it's not a perfect circle is, well, it's a very good rule of thumb, and I probably should have said this in class, but it's a good rule of thumb to figure out this up here. All we have to do to figure that out is go halfway in between our two intercepts and then find out the y value, and we got 21. Then when we take the square root of 21, we get, let me do that again, we get about 4. So 4 is here. And then if we take the square root of 8, we get 2. We can see that's creating like that, it's not a perfect curve. So it's a bit bumpy. And that's why the answer's like that. And then we have just, of course, have the same that's reflected upon the bottom. So again, those are the only ones in the answers that are a bit bumpy, which is why I chose those ones. A good rule of thumb is when you have big questions like these, It's a good idea to find your turning points, and that's exactly, remember, exactly halfway between your two intercepts. Then you plug that halfway value into your formula, and then you will get the turning point. Then when you take the square root of the turning point, you'll get a number. Take the square root of the y-intercept, you'll get another number, and then we can form this pretty little bumpy curve. Alright, hope that makes sense. Have a good weekend as well. See ya.